we decided to do our physics project on how planes fly.
Hey, what are you guys doing for spring break?
I'm going to California.
I'm also going there.
That's cool. I'm excited, but I'm kind of scared because I don't know how airplanes fly or work.
Oh, same.
Oh, you'll be fine. They're super safe. Here's a video to reassure you. The airplane has 4 forces: thrust, drag, lift, and weight. These 4 terms are a very similar concept to what we learned earlier this year with the free body diagrams. Thrust is like the pulling force. Drag is like the force of friction. Lift is like the force normal. And weight is like the force due to gravity.
In order to maintain a steady flight, there needs to be an equilibrium of all those forces acting upon the airplane. Furthermore, planes stay in the air because there is no net force, so F net is equal to 0. This reminds us of Newton's first law that states an object at rest stays at rest, and an object in motion remains in motion.
The wings of the airplane are also called airfoils. The wings play a large role in keeping the airplane flying. Airfoils are designed to have good aerodynamics to reduce the drag. The shape of the wings allow the airplane to have a steady airflow, which is also crucial for the plane to fly. The curved shape of the wings and their slightly inclined angle allows for the bottom of the wing to smash hard into more air molecules compared to the top of the wing. Because the air pressure is greater below the airfoil than above, a resulting lift force is created. A good analogy for understanding the concept of airplane wings is this. Imagine you're in a moving car and you put your hand out the window vertically. I bet you'll feel a lot of drag. Now imagine you're still in the moving car, but instead you put your hand out horizontally. I bet you won't feel a lot of drag. In this case, your hand is aerodynamic. This is the reason why airplane wings are designed to be flat and horizontal.
Now that we've talked about how airplanes use wings for lift, we are going to talk about jet engines. Jet engines are what help make the plane accelerate forward, also known as thrust. The propellers are another form of engine. They spin to push the air backwards. This is what helps make the plane go forward. Newton's third law of motion is used here because it states for every action there is an equal and opposite reaction.
The first formula is to find the drag of the airplane. It is where d is the drag of the airplane. Greek letter rho is the air density. CD is the coefficient of drag. And v is the velocity of the plane.
The second formula is to find the lift of the airplane, where L is the lift, rho is the density of air, v is the velocity of the aircraft, SREF is the reference area. It is the area of the wing hand viewed from overhead. CL is the coefficient of lift.
Now we are going to use this equation to do a practice problem. This report provides the following information for a Boeing 747 during a high altitude cruise. So first, let's write what is given in this problem. The reference area, SREF, is 510.97 meters squared. The density rho is 0.30267 kilograms per meter square. The velocity is 265.5 meters per second, and the coefficient of lift is 0.52.
Now what we are trying to find in this problem is the L, or the lift. Now we need to state the formula, which is... Now we plug in the given information and solve.
And this comes out and equals 2,834,400 newtons. This means that it takes 2,834,400 newtons to lift the Boeing 747 aircraft that is going around 265 meters per second.
Well, that video taught me a lot. Now I'm not